Question 30. A manufacturer of car batteries claims that his product will last at least 4 years on average. A sample of 50 is taken and the mean and standard deviation are found. The test statistic is calculated to be negative 1.48. Using alpha is equal to 0.05. The conclusion would be what? Okay, so let's find the original claim, which was said that the average was at least 4 years. So mu is greater than or equal to 4. Okay, the opposite of that would be mu is less than 4 years. So from that I can get h sub 0, which always has the equal sign, and h sub 1, which never has the equal sign. Okay, so which one, either the null or the alternative, is the original claim? Well, this is the original claim, and that is the null. Okay, so I'm going to write claim right here. Okay, and also from the alternative, we know that we are in a left-tailed test. Notice which direction this sign or symbol is pointing. It's to the left. Okay, so we have a left-tailed test. Okay, so from here, we've got two options. We can either do the traditional method or the p-value method, because it didn't give us, it didn't tell us which one to use. So if we look at the traditional first, okay, so it is a one-tailed test. It's a left-tailed test. So what we need to do is, let's go back and review what the traditional method is. Okay, the traditional method, it uses the level of significance, or alpha, to find the critical value. Okay, so if the test statistic falls within the critical region, reject h sub 0. If the test statistic is outside the critical region, fail to reject h sub 0. So we need to use alpha to find our critical value and where it is within the normal distribution, if it's in the critical region or if it's outside the critical region. Okay, we were given an alpha of 0.05, but we are in a one-tailed test. Okay, now the alpha that is given in this table, these are two tails. So that means that the area has been split up between two tails. Now, all we have is just area in one tail, that's 0.05. Looking at this right here, this is a left tail test. So right here in this area is 0.05, whereas that table here is giving us, let me move this up just a hair, okay, area in two tails. Okay, so what we need to do is we need to make our one tail look like a two tail test. Okay, so we're going to take the area that we have here and multiply it by 2, and that way we'll have area in two tails. Okay, so we're going to go back to this, and we're going to find our alpha, which is 0.05, and not find it, but we're going to take it and then we're going to multiply it by 2, and then we can come to this table and find our alpha. So let's do that. Okay, so we're going to take our alpha, which is 0.05, and we're going to multiply it by 2, and that's going to give us, I'm going to do that, 0.1. Okay, that alpha is in two tails instead of one tail. So now we can go back to that, that chart and find our critical value. Okay, so 0.1, and here it is right here, 1.645. Now don't just grab that and say, okay, hey, my answer for the critical value is 1.645, because notice that we are in a left tail test. Okay, so our z-score is going to be over here, or critical value is going to be over here, which means if this is the mean right here, everything over here is going to be negative for our critical values, and everything on this side over here is going to be positive. So since we're in a left tail test, our critical value is going to be negative. So we're going to have a negative 1.645 for our critical value. All right, so I'm going to write negative 1.645 right here. And they said that our test statistic was negative 1.48 in the question they gave us, which is, we'll say, about here. Okay, so this is our critical region. Okay, so now we're looking at the test statistic, which is that negative 1.48, and we're trying to see, is it in the critical region or not? And we know that it's not by looking at it here. Okay, so the test statistic is outside of the critical region, and based on the traditional method, we know that we are going to fail to reject h sub 0. Okay, now let's go back and use the p-value method. Okay, so the p-value method, since we are in a left tail, okay, so left tail, so the p-value will be the area to the left of the test statistic. Now we know that the test statistic is negative 1.48, so let's go to the z-score table and try to find an area associated with that z-score or that test statistic. Okay, so here is negative 1.4, and then I need to scoot up here until we get to the 8. Okay, so scoot over, and there's 8 right there. So it looks like our p-value is 0.0694. So everything is the same, finding the original and the opposite claim and getting h sub 0, h sub 1 from that. Now we just said that our p-value is 0.0694, and with the p-value method you always compare that to alpha. Okay, so if the p-value is less than or equal to alpha, we're going to reject h sub 0. If the p-value is greater than alpha, fail to reject h sub 0. Now they gave us alpha is equal to 0.05. So I'm going to compare these two numbers together. So 0.0694, compare that to 0.05. Looks like this number is bigger. This was our p-value, so p is greater than alpha. Okay, so if the p-value is not low, then the null must not go, or we will fail to reject h sub 0. So it doesn't matter if you use the traditional or the p-value method, they should both come out to the same exact result.